The next Java collection we are going to look at is a deck, which is a container with two ends called front and rear, where the elements can now be added both from the front and from the rear. So the only difference between a FIFO queue and a deck is that in a FIFO queue, we can only add items from the back and remove items from the front. But in a deck, we can add items both from the front and from the back, and also remove items both from the front and from the back or the rear. So here's an example. Let's say this is the initial deck. We now say add last, which means that 6 now should be added at the back of this deck, so 6 goes to the end. But if we say add first 7, then 7 goes to the front of the queue. So now you could, as you can see, you could add at the back or at the front of the deck. And similarly, we'll have add remove last, remove first. Remove last is going to remove the last element of the deck, and remove first is going to remove the first element of the deck. Here is the inheritance hierarchy. As you can see, deck is an interface, and the concrete class we need to instantiate to create a deck is a linked list. And here are the major operations in deck. Add first adds the element at the front of the deck. Add last adds it at the rear or the back. Remove first removes the element at the front of the deck. Remove last removes the element at the rear or the back of the deck. Peek first is going to look at and return the element at the front of the deck without removing it. And peek last is going to return the element at the end of the deck without removing it. Obviously, because deck is extending queue, which is extending collection, we also have is, empty, size, and clear methods. And here's how we can use it. Again, we are instantiating a linked list. That's our concrete class. And then porting this reference variable to a deck. Now I will be accessing a linked list through the methods of the deck. So I'm just adding last 10. So I'm adding 10 to the end of the deck. So initially the deck is empty. Now it contains only 10. Now add last 5, so 5 goes to the end, so the deck is now 10 and 5. This time I'm doing add first 7, so 7 now goes to the front of the deck, so the deck becomes 7, 10, and 5. If I say peek first, give me the element at the front, it will be 7. If I say peek last, give me the element at the end, that will be 5. So I did not remove them yet. Now I'm removing the first element of the deck, so 7 will be returned and removed from the deck. So the deck now contains 10 and 5. This time, if I say peek first, I should be getting 10. What is the size? It's 2. And is it empty? No. Now I say remove last. That's going to remove 5 and return, and then remove last. So 10 will be removed. And if I now ask, is the deck empty? And the answer. Here is the actual code. I am instantiating an object of linked list and porting the reference variable to a deck. So I would like to access a linked list through the methods of a deck. So I have add last, add first, and add last. So as you can see, I can add elements both to the back of the deck and also front of the deck. Then I have operations to get the size of the deck, to get the element at the front of the deck, at the end of the deck, and then I can remove the elements from the front and from the rear. Then I have, in a while loop, I am removing the elements in FIFO order by saying deck.remove first. So let me run this thing and discuss what the output is. So I have a couple of add last, add first methods. Then I'm asking how many elements does the deck have. It's 5, obviously. Then I'm saying give me the element at the front of the deck. It's 1. How do I know that? Because look at this. The last element that I added to the deck through add first is 1. That's why 1 is at the front of the deck. And what's the element at the rear of the deck? It's 9, because the last add operation is add last 9. So 9 is at the end of the deck. That's why I'm getting a 9. So I'm now saying remove the front of the deck. Obviously 1 is now removed. So the element now at the front should be 7, as you can see. So that's what it is. So if I say peek first, it should return me 7. Then I'm removing the element at the rear, which is 9. And the element that would be at the end would now be 3, as you can see, and that's what I'm getting. Is the deck empty? No. So then I'm just going to get the remaining elements of the deck in FIFO order. So that would be 7, 4, and 3. And is the deck empty now? Yes. So again, the only difference between a queue and a deck is a queue is a single and a is a FIFO queue where you can only add items at the end,